Guys, in today's tutorial we are going to be working on the summary of all the things we have done in the courses. And I brought all my time to bring out like 50 questions. It's combination of everything that we have done since course 1. So if you want to understand what we are going to be doing today and be able to take the quiz along with us, make sure you have done the quizzes for course 1 to 5 so you won't miss out. And hope you guys like my new design interface of my new web app for this summary. I think it's too childish or something, but I just wanted to use it. So if you go through my courses, the first, second, third, fourth, fifth, please comment the best design so far. So I'll keep it consistent in other quizzes I'll be bringing out in other programming languages. So these are the things we have covered for the courses from 1 to 5. So this is the summary of everything in our small cheat cheat sheet in this program now. So we covered number systems, scientific notation, set theory, Boolean logic, and algebra, and combinational logic circuits. Okay, so this is just the normal thing that we covered throughout our last courses. So if you have not yet done the thing, I'm going to say it again. If you haven't yet watched all of my course videos from course 1, just go. All you need to do is watch the video to understand what the concepts, then download your download or I mean click on the link in the description for my I published it in GitHub so you can take your quiz as well. So if you are done watching the video, make sure you copy the link or just click on it and it takes you to my web app here so you can do your own quiz because it randomly generates quiz for you on every interface. What I mean is this. So if you start quiz, you save a question on the quiz. So I don't like this interface that much. I was trying to copy Who Wants to Be a Millionaire. I don't know if you have seen something like that. The way they structure their questions. I was trying to do something like that as well for our summary. But anything, I think it's cool this way, but I'm going to change it though. And I think I'm going to give like a pink or something, but let's just keep going. So if you see the question for question 1, so if I should restart my quiz and start it again, you see the question changes. Let me restart it again and the question just changes. So it changes for everyone. So make sure you go to the description of this video and make sure you have watched other videos as well. The course 1, 3, course 1, 2, 3, 4, and 5 on different topics. On number systems, scientific notation, set theory, Boolean logic and algebra, and combinational logic circuits. Okay, so this just the same thing. Make sure I watch the video so we can start the quiz. So okay, so that's it. So and make sure you subscribe for more quizzes and more programs like this. I'll be publishing the quiz in my GitHub and I'll put it in the description so you can get access to the quiz app as well. The quiz app, web application formats, and other programming languages as well. So for the first question, and output is 1 when input mm, and output is 1 when inputs are 1 and 1. You see the interface I created. I was trying to make it like all those who wants to be a millionaire. But I hope this interface is great. But I think I prefer my last interface to this. I'll just keep the same structure for all of my programs though. But I don't like this interface that way. But I just wanted to show you guys if you like the interface of this my web application. Okay, so you can also check summary because this my new functionality I added. You can view summary of your notes of the notes as your cheat sheet and stuff like that. So you can view summary of the app and stuff like that. So let me just cancel it out and go off. So that's it. So and output is 1. Make sure you answer your own questions. I have like 50 questions on this, 50 or 60, I think. I added like 50 questions on this quiz app. So it generates random questions for you guys. So submit answer correct. Same thing as it we do in our other videos. It shows you if you're correct or if you're wrong, and still gives you out the solution on how you got it. So no need to read the solutions and stuff like this for like that. So this video won't be that long. I've already given you guys an explanation on each solution that I wrote down here. So once you answer your quiz, if you can't, if you failed it, you'll see the solution and explanation, a very brief and understandable explanation down there. Okay. So we'll go for the next question. We have which notes this is correct, okay? Submit. So I'll just be going through everything quickly. Next question. We have a full adder adds 3 bits. Submit. Okay. So make sure you go through other videos 1, 2, 3, 4, and 5 of our courses and you understand the thing. Once you have taken the quiz there, you will have a very cool concept, a very good idea on how to complete this our final quiz. Okay. So for this union it would be 1, 2, 3. So next question we have decoder are combinational. I think it's true. Decoder, yeah. So it gives you a response down there for explanation of why it's true and why it's false and stuff like that. Octal 17 in decimal is I think 14 or 16. In decimal, I think 14. Oh god. Oh, 15. 15. 15. I thought that's much. I thought it's 15. Yeah. 15. So next. Yeah, true. True. Scientific notation standardizes these numbers for efficient floating point operations in computers. So next, F equals this A plus B plus this. It would be A. I think it's A. Correct. Okay. This is the complement law from our last course 5. So binary 1.2 is in decimal is 1.11 times 2 raised to power 3 in decimal is let me just say 14 or 12. Oh, yeah. So A and B for A this. So A intersection B, I meant to say, for A 1, 2, 3, B 2, 3, 4. I think intersection would be 2 and 3 because it's here and also here, so it's 2 and 3. So I mean it's correct. Next. Sets are unordered collection of unique elements. Yeah, true. Submit. Next. Decimal 13 in binary is okay. How I usually calculate something like this is okay. If you see decimal 13 in binary would be so you count the one that is 13. This ending is like 1, this one is 2, this one is 4, and this one is 8. So 13 would be, I think, this one, because with 1, 2, and 8 will give you 11. No, 1, 4, and 8. Yeah, yeah. 8 plus 4 plus 1 will be 13. I think. Correct. Okay. So it gives you the solution on how it's found. The next one, simplify a this a and so this like a and I think it would be this. Let me see. Correct. Next, so next one, which is equivalent to a XORB. A XORB would be one of these two, I think, boys. Yeah, I know it's that. So next, convert 42 to hexadecimal. Hexadecimal would be this. Correct. So you can convert it yourself. I have an idea of the answers because I'm the one that made the equation, so that's it. So I I didn't like calculate it very fast, you know. So a plus a times b would be a, because a or this is like or anything that it wants to bring is always a. So correct absorption law for that we did in our last course 5. So the next one we have scientific notation for this would be 1 2 3 dots. So there's the answer. So since we are going backwards is -3. Yeah, move decimal 3 places right. 1 2 3. So or produces 0 when inputs are or produces 0 when inputs are 0 and 0. So submit your answer. So when inputs are 0 and 0, so go for the next question. Which gate is functionally complete? Oh, XOR or NAND? NAND. I think it's NAND. Which gate is functionally complete? NAND, not AND. I know. I know it's the correct answer, not AND. Next. Convert oh, this cool because F is 1111 and FF is 11111111 for hexadecimal to binary. Take note. Okay, so you see the solution here. Next question. Hexadecimal 1A is in decimal is, let me just say 26. Correct. Next one. A2 to 4 would be 4. No. A2 to 4 would be, has how many output? I think 4, yeah. 4. I thought as much. Next, which binary 1011 in decimal? So this one is 1 plus 2 plus 8. 8 plus 2 plus 1 is 11. So you submit answer, you see how the long way they got the answer, but I just quickly got it because that's my thing. So next one is the Morgans. The Morgan's law will be this. So this complement would times everything here, so it would be this, and it also changes the sign here. So it's this. So if you yeah. So the Morgan's law, that is how it works. It's quite confusing, but if you have a very clear knowledge on it, it's quite cool. So the next one, we'll go to the next question. So if I try to select an answer without putting anything, it gives me this, please select an answer, please. Then a little bit smiling emoji. Then this would be this, okay, by De Morgan's law, because it changes the symbol as well, times everything here, and also changes the symbol. We did it in our last course 5 though, so make sure I've watched other courses as well. So XOR is true when exactly one input is 1 is true. Exactly one input is 1. So that's the answer for that. So for the next question, we have binary numbers are used in computing because they match digital circuits. And the next question is, yeah, it was a, so it's true. You submit. Next question. Combinational circuits depends on present inputs. So submits are memoryless. Output depend only on current inputs. So at binary addition 101 plus 11. So 110. You carry the 100 110. So that's the answer for this 1000. So next question, we have some output of half other is equals some output of half other is equals I think it's so, and I don't know. Correct. I know it's exclusive or. So next question. I said that we have like 50 to 60 questions on this quiz. So make sure you take yours and get your own question. I think it's A. Sorry. I think it just slowed down my system a little bit. So okay, absorption law. The answer is A. The next one, Boolean algebra is used here in database queries, yeah, and many other programming languages as well. Next, octal digits are from octal is base 8, so we don't exclude the 8, so it's 0 to 7. Okay, so next question, NOR gate outputs 1 when both outputs are 0. Next question. So 1110 minus 0 1000. I think it's this. Okay. Next question. Normalize 0.00045 to scientific notation. We have 1, 2, 3, 4. So this it's yeah. Okay. Simplify this plus this would be this plus this would be, I think this. Okay. Yeah. So the next one, 4 times 10 raised power 4 times, in parentheses, 2 times 10 raised power 3. So what we're going to do is 4 times 2, 8. We'll add exponents. 4 plus 3 is 7. So 8 plus 10 raised power 7 is the answer. Yeah. How many select lines from 16 to 116? So I have 4, 4, 4, 4, 4. 4, I meant to say 4, 4. Binary scientific notation for this is equals, you count 1, 2, you count 1, 2. So it's now this. Next, a half adder requires which gates? XOR and sorry, it's yeah. Next, full adder sum is XOR exclusive, or I'm calling it XOR. I don't know why it's part of me though. So exclusive OR is what it's called, exclusive OR. So the next one we have so this one, since there's addition here, we're going to add everything, and we're still going to keep this because it's still the same exponents, 3 and 3. So 2.5 plus 3.5 is 6. 6 times 10 raised power 3. Okay, so you see that. So the next question, NAND gate is equivalent to NAND, not AND gate is equivalent to not AND, not. You say the not operator here, then this 10 means AND, this dot times means AND. Next. Sum of product form is used to simplify circuits. It's used to simplify circuits. Okay. So next, which circuit selects one input out of many? Multiplexer. Multiplexer, MUX is what it's called. This, what is this? So this De Morgan's law. So we times everything here and even change the output. So this would be this, De Morgan's law. Yeah. Next, combinational circuits use clocks. Okay, combinational circuits use clocks. I think it's false. Wait, do they use clocks? False. Let me see what. Yeah. Yeah, combinational circuits are memoryless and do not rely on clocks, unlike sequential circuits. So the answer is false. Next question, we have identity law. A plus 0 is equals. So this is like all. So A plus 0 is equals A. Because anything plus 0, even true plus false, is always true, or false is always true. And anything false, sorry. Yeah, that's it. I think it's A or 1. No. Yeah, identity law. A plus 0 is equals A. So let me see my grade now. Okay. Maths mastermind, computing genius. You can see my grade, 94.00%. That is probably an E for this. So your score is 47 out of 50. I feel like 3 questions, and they gave me my grade as well. And that's how the interface I used for this particular program now. So you can see it's a cool interface, and I hope you guys liked it a lot. So make sure you go to the description of this video and get your get the link of the GitHub, my published GitHub for my web application, for this application, so you can do your own quiz, get your own question, and test your understanding. And make sure you like, comment your score, and subscribe as well. Love you guys.